Hello, everyone. Thank you for joining us today as we come together to learn more about Kubernetes by example. My name is Hassan Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Rory Preddy. Rory works in the developer relations team at Microsoft as a senior cloud advocate for Java. Cloud advocates use their deep research skills to help professional cloud developers discover successfully how to use Microsoft platforms. A seasoned speaker whose talks are both meaningful and humorous, Rory travels around the world empowering developers to achieve more. Feel free to ask questions during the session. We have a Q&A tab where you can post your question, and also we will be having regular stops to answer these questions. And also feel free to engage with us on socials and tag us on Twitter, Reactor Abu Dhabi, and MSFT Reactor is the Twitter handle. And also it will be great to adjust the playback settings to select the highest quality to enjoy the best experience in today's session. And with all that said, I hand over the mic to our speaker to start the session today. I just have a little issue with the audio. I'm trying to unmute. Can you try on your end, Rory, please?
Yeah, you muted me and then you can't unmute me. That's pretty hilarious.
Exactly. All right, all good now.
Yeah. I didn't mute myself. Okay, cool. I wanted to say if there at any given time there's any technical difficulties, just tell me what's going on. The slides aren't working, or if the text is too small. We've got a lot to cover today, so I want to make sure that I bring everyone on this journey with me. And today we're going to cover Kubernetes by example. I'm going to do a nice example. I'm going to do 30 minutes, under 30 minutes of slides, and then 30 minutes of a demo. And then hopefully by the end of it, you'll get a good feel. And this is a basic introduction to Kubernetes. Kubernetes is a rabbit hole. You can go so deep into it. And I'm going to show you how to get started by using a nice Java example. And by the end of it, you'll be able to say, hey, and I know the basics of Kubernetes. So first, if you want to follow me on Twitter, you can go at Rory Preddy on the slide. You can also go to all of these slides and also a little bit more information on the slides, and also demos, labs, and information on how to get started. The code is on aka.ms/Kubernetes-Java. You can also put that QR code with your phone camera. It'll take you there through also. So who am I? I'm Rory. I'm a cloud advocate, and I've been in advocacy for 10 years. I've been in development for nearly 23 years, and I don't want to make Kubernetes sound too easy, so I'm going to tell you a little bit about the hard stuff also as we progress through there. And this URL is also going to be available at the end of the presentation. We've only got 5 real categories we're going to cover today. We're going to go through container challenges, why you need an enterprise container management system, what is Kubernetes, the history behind it, what are the core parts of it, the tool set, so how do you get started with it, what are the command line tools, then the architecture and components, so all of the small little pieces and pies to what you hear with the pods and the nodes and the deployments. We're going to go through briefly around that, and then I'm going to do a demo, and I find the demo really helps as long as the demo works. So I've lost more Kubernetes clusters than I've had warm meals. So, and I just did a talk like 3 days ago where my Kubernetes cluster wouldn't come up. So hopefully that won't happen. So let's start immediately. I've got 55 more minutes to show you Kubernetes. So first, let's go through container challenges. Yes.
Quick one, Rory. I need you to start again sharing your screen so that I'll be able to push it as well.
Okay. There we go. Share my screen and add content from below. Share my screen. There we go. And I want content. There we go. And do you want me to hit send live?
Yes, if you want, or I'm gonna, I prepared the queue.
Just did it. Okay.
Go ahead. Yeah,
Okay,
perfect.
There we go. Presenter view. Okay, so presenter view. Let's start with container challenges. And I think that the idea behind container challenges is that anyone who's worked with Docker or anyone who's worked in software understands that software suffers from complexity, invisibility, changeability, and conformity. Those are the 5 essential difficulties with software, and containers also suffer from that. And trying to manage millions, if not billions, of containers in a large organization is very difficult, and things can get complicated very easily. And what we really need is a container management system that handles some core properties. We're going to go through those core properties one by one. So we need a container management system that manages the cluster. You have more than one container and informs a cluster. So you need to deploy and manage the cluster resources, because I don't want to have to manage the resources. And we like to use the analogy of something called pets and cattle. When you name a pet, I have a pet called Princess and Champ, the dogs. They mean something to you. And you name a server, like the normal tin servers, you give it a name like Obelix or Asterix or Saturn or Mars. You don't want to name a pod. You want to just chuck it into the ether and let the container manager manage it. And we'll use that metaphor going forward and quite a few times to understand how to do container orchestration. So 1, we want cluster management. 2, scheduling. So if I have an app that I want to push at a certain time to a number of containers, I want it to push it to there, but I don't want to have to manage the up and down and the actual allocation to those nodes and at a specific schedule, depending on rollback or roll forward. I want to schedule it to be able to do that. Health and life cycle. If a pod actually is sick, just get rid of that pod. Why is that so difficult? It's like the idea of cattle. If the head of cattle is sick, it's a number in a number of cattle. You don't kill Princess or Champ, the dogs. You kill a head of cattle, and you want to keep the containers running despite failures. You want to be able to say this failure is affecting it. Bring it down, bring it up again, and then alert me if there's another issue. Naming and discovery, where are my containers? I still want to know how many and where they are, and I can give them labels there, similar to branding cattle, that you brand it, and it's not got a name, but it's got a number, and you can kind of say, allocate that to some kind of resources going forward. Load balancing, the demo, I'm going to create a load balancer and load balancer to evenly distribute traffic. If I've got 1 million containers and they all do the same thing, I want to balance that load and be able to access those containers via an ingress or a load balancer. Scaling, so make sets of elastic containers in number. This is really where the cloud comes in, because the cloud has, in your mind, infinite number of containers, an infinite number of servers. And if you want to kind of scale internally in your own network, you have to kind of use up all the resources that you have. But externally, you can scale out to your heart's content. Image repository, so you want to keep those images there, centralize, internalize, and you want to secure those container images. And in Azure, we have Azure Container Registry. You can also use Docker Hub or a private registry. Continuous delivery, CI/CD deployment. The demo that I created today that I'm going to go through there, I used the CI/CD from Azure DevOps to actually go and create my cluster, and we'll see how you can do that. Monitoring and logging, and also distributed tracing. So monitoring and logging and what's happening in your clusters. And then finally, storage volume, persistent data for those containers. So this is what we want our container management system to do. And at the end, we need something to help with all of that, an orchestrator. And there are many orchestrators out there. Actually, I did a talk yesterday on Azure Spring Cloud, which is another orchestrator. It actually sits on top of Kubernetes and does your Spring orchestration. But there's so many different to choose from: Docker Swarm, Apache Mesos, Nomad, Rancher, Service Fabric, and then finally Kubernetes. And Kubernetes really is the gold standard, because it's tried and tested. in enterprises. And it's also, it has some features that we're going to go through today that really lend itself to the container management system we're looking for. Let's go back in history and see exactly where we found Kubernetes and why it was so suited to what we're looking for. So what is Kubernetes? And the code name is K8. So K8S, you take the name Kubernetes and you kind of shorten it into K8S. And Kubernetes is an open source platform for automating deployment, scaling, and management of containerized applications. Simple enough, but it also in Greek, it's pronounced Kubernetes, and it means helmsman or pilot of the ship. Imagine a big container vessel, a ship, going through a port or a harbor or somewhere like that, and then on top of that ship is all these containers, and you're taking them somewhere out. And I, as the captain, is telling those containers where we're going to go together and kind of getting them to that point. And that's what Kubernetes stands for. It's an orchestrator. And keeping with the maritime theme of Docker containers, Kubernetes is the pilot of the ship of containers. So history, so originally it was defined by Google, and now it's maintained by the Cloud Native Foundation. Just the other month it was elevated to a published platform in Cloud Native Foundation, so the highest level you can get of maturity. Google's still actively involved, and Kubernetes 1.0 was released in July 2015. But before that, it was actually called Google Borg. So you can access the URL at the bottom there, large scale cluster management with Borg. And what Google did was that they had billions of container images. Every time you had a Gmail instance, you would spin up a container. Every time you had a search engine, it would spin up a container. And they needed a management system to be able to do that. And it's actually called Google Borg over the Star Trek Borg, that they wanted to create an automation engine for containers. So what are its features? You've got self-healing. So it knows about a pod if it's not acting right, on how to fix that pod. It's got horizontal scaling, so you can scale out. So 1, 2, 3, 4, 5, 6 number of pods. You can get automatic rollouts and rollbacks. So you can say, here's a version of a pod, roll it forward or roll it back. If there's something, an issue with that rollout, then roll it back. Service discovery and load balancing. So if I've got a service with a label and I chuck it into the cluster, it will kind of alert the cluster to where it is and what its status is. And load balancing, if I access that through a port or a URL, it will kind of find where I'm supposed to go. Bin packing, storage orchestration, and then secret and configuration management. Now, if you go through the URL for the slides, I go through the bin packing, storage, and secret management in a lot more detail, but we're not going to cover it there. So let's go through the Kubernetes building blocks. And Kubernetes is made out of really a central manager called a master, and also some worker nodes. So you can see here on my left is the master components, and then we have the node components. You can think of the master as something called a control plane. And the control plane kind of says, I have a cluster, it's my cluster with all my components, but I still need to manage it with certain components. And it really is created from the need to have a API server, a controller manager, and a scheduler. So the API server is just your input into controlling Kubernetes. Your controller manager is handles your replication, your namespace, your service accounts, etc. And then finally, your scheduler goes in and allocates the nodes at a certain schedule. On top of all of this, we have a distributed file system and protocol called etcd. We're going to go a little bit more detail there. That kind of manages all of the container and the protocol and the communication between all of the components, and make sure that we have a secure channel to do that. On the node components, and we're going to go through that a little bit more details. We have worker nodes, and each one of those worker nodes, which might be a physical server, or it also might be a virtual server, like in Azure, you're running on virtual servers. Each one of those worker nodes has a kubelet, which is a management component to manage the kind of the life cycle of the node. Then it has a kube proxy, which proxies the API server. And then you have your Docker image, your Docker maintenance kind of layer. which then manages all of your different containers. And those interact with the kubelets and the kube proxies, and then the kubelets and the kube proxies speaks to the API server, who gets its information from the controller manager and also the scheduler. And that's how all of these nuts and bolts work. And we're going to go through it a little bit more detail as we progress this. So how do you access all of this? And the best tool to use is kubectl, or actually called kubectl, or I call it kubectl. And it's basically a command line. We're going to be using that extensively. And then we're going to go, once we've got our Kubernetes cluster in our demo, we're going to go into the cloud and also in Azure portal and see how you can use some of the nice features of Azure Kubernetes services on top of kubectl. And kubectl then ties into the API server. It's a wrapper around the API server. Let's go a little bit more detail about the master components. So you've got the kube API server, like we said before, the front-end control plane, and then exposes the API. You can also access that API via RESTful services if you really wanted to make your life a little bit more difficult. Then we've got the controller manager. It runs the controllers, replication controllers, node controllers. I'm going to show you replication. So in my demo, I'm going to spin up some nodes, and then I'm going to add some replication to it. And you'll see that the replication controller is going to say, oh, wow, you're asking for 2 of these nodes and you only have 1, and I'm going to go make sure that I can find and allocate another one for you. Then the scheduler assigns pods to nodes, and it's also very clever. Now, there's something that we're not going to cover today, but there's something called taints and tolerances. If I have a node running on some physical tin that has a GPU on it, a graphic processor, I can actually taint that server and say this is a server that has a GPU in it. And the scheduler will go in, and if I have a pod that says I need a GPU server, it'll allocate to that node there. And it's clever in the sense that it knows what I'm asking for and what it can actually allocate. Then we have etcd, highly available distributed cluster database, but it's more than a database. It's also a file system, and it manages across the control plane to get all of those protocols and the communication across all of your systems. We also have a ton of add-ons. We have everything from DNS, Heapster, dashboards, logging, and all of these other systems that allow you to tie into Kubernetes and add on certain functionality on it. A little bit more about the worker node components. So we have that kubelet. Remember I said to you that little component there that manages your worker nodes, and it's the primary node agent, watches and assigns the pods, and then executes health probes and reports the statuses. It's like your little heartbeat, boop, 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 to see what's going on in your pods on your worker node. Remember, so what people get confused around also is node to pod, the topology around that. In the interest of complexity, we're just going to say a worker node is a server, and a pod really is a component, a Docker pod running on that server. You can get a lot more complexity around that because theoretically a worker node isn't really a physical server, it might be a virtual server. Then we have the kube proxy, enables the network services. And then finally, we have the container runtime. And now there are quite a few container runtimes. I'm not going to go through it in the space of this session though, but understand that the container runtimes that Azure use is called containered, but there's also other ones that other services and other implementations of container orchestrations use. So you can go look that up in your own time around that. So we're making good for time. Let's look at Kubernetes resources. So how do you access the Kubernetes resource? And there's 2 ways really. Both are very controversial because both actually give you a little bit more or a little bit less. So the first and the easiest one I like to use is the imperative and declarative way is the imperative way. And we're going to be doing that today. I'm going to show you a little bit about the declarative way. And the imperative way is really running kubectl on the command line. And it's exactly what you want. The declarative way is using YAML, and you'll know that this is very controversial because YAML is got white spaces there, and it's hard to work with. But it's you really go you have kubectl, you define your YAML file, and then you do your deployment or your service via a YAML file. What is a pod? So a pod is your basic building blocks in Kubernetes, and a pod can run on a node, if you remember. So pods are containers that are delivered. There can be multiple containers, and I give an example here of a sidecar. So sidecar is a service that runs a build, and then that build inside the node then pushes it to another pod right next to it that allows you to kind of run your service though. These might be these pods with these sidecar pods might be on a physical server. They also might be on 2 physical servers, but in the mind of Kubernetes, they're actually in one worker node. And then a pod also encapsulates the container storage, network IP, and options on how to run. This is the YAML of how to create and define a pod. We're going to go through step by step. So you can see there, I've got API version, kind, metadata, specs, containers, and then other features. So the first thing you want to do there is you're going to define a pod so they will know, wait a second, this is a pod, it's not a load balance, it's not a service. You're going to have the metadata if you want, labels, and we're going to go through labels now. Also, you've got the containers, and these are the containers that you already have defined, and it's going to pull from a registry. And you can see here name, key value store, and that's the name, the definitive name that I'm giving that container. Then we have also multiple, you can see there are multiple containers, and this is one pod, and it's running a key value store, and also another container there called front end. And this is running on worker nodes, and there might be many worker nodes running many pods with many containers in it. And that's the example here. This is a Redis pod there that is running Django, that it also has a key value store. So this is another example of a manifest. And you can see here requests, and requests specify how much resources a container needs. And you can see here I've got memory, 64 megabytes CPU, and limits there. And a lot of the languages, .NET Core, Java, Python, have actually changed the way that they operate, because they've realized that they need to actually look at what the container requests and resources is limiting them to, and not ask for more. So since Java 11, for example, it kind of is aware that it's running inside a Docker container, and it won't kind of ask for more resources than what is available via the Docker container. And then you have limits, which I've already specified. How do you interact with pods? So I've got some nice commands here. Let's see. So first of all, if I wanted to get all the pods in a namespace, and a namespace really is something that I define, and it basically is a collection of pods. So I go kubectl get pod and all namespaces. It's going to bring me back all the namespace here. You can see here I've got all the namespace, the name of the actual pods, and then the status ready, ready, and how many of those are ready. If I wanted to have a replicate set of more than 1 or 0, the status, so running, terminated, unknown, the restarts, how many times this is restarted in case you want to know the health, and then the age of how many times you created that. If I wanted to describe a specific pod, then I would go kubectl describe my pod, and you'd get all of the specifics and in YAML format. So you have to know the declarative way of accessing it, because it really, when you run the imperative command kubectl describe my pod, you get the declarative back in the YAML. If you want to access your logs, you go kubectl logs and then the pod, and you'll get back your logs of the running instance. If you wanted to run a command also, you can also run a command. Remember, these are most of the time Linux actual pods, and you can go kubectl exec, and then you do it it. My pod is the pod that you're accessing, and bash. So you can run inside the pod that you're going to be accessing it as a normal Linux container. Let's go through labels and selectors. So labels and selectors, they're key value pairs for any API objects and Kubernetes, and a quick way to kind of find the pod that you're looking for, and they queries against labels to match objects. Those are called label selectors. So the use case of that, you associate pods to a service, you pin workloads to specific nodes, and you select a subset of resources. Controllers, and in the demo we're going to create a controller, and that's a deployment. So deployments provide declarative updates for pods and replicas. Most of the time we're only going to work with deployments, because when you deploy, you also specify the pod, the service, and a lot of the features. Think of deployment as the meat and potato for your access to the pod. You just say, I want something, deploy it. So use cases, create deployment to roll out a replica set. A replica set is how many pods you want. Declare a new state for pods, roll back to earlier versions, scale up or scale down, check the rollout history, and clean up older replica sets. What does it look like? So we've got the YAML here. We define the kind as deployment. Then it's going to actually create 4 replicas in this example here. So the spec there, which is the specifics of the kind, we're going to do 4. And then we're going to say, out of that 4, please go create 4 of that spec of that container. So this is a deployment, and I'm going to say I want 4 of what I'm going to define, and I want 4 containers deployed. Where are you going to deploy it? I don't care. I know you have the resources. If you don't have the resources, tell me you don't, but just go deploy it, find your servers of your nodes, and just deploy it. And lastly, we're going to take the image that we're going to use and the container port. So the image is from the registry. Now, by default, it uses Docker Hub, but you can use ACR registries. And then also the container port. And this is the port that we're going to open up to the Docker instance to the cluster. This isn't the load balancer. This is the port we're going to open up for each of the instances of the pods to the cluster network. And the cluster network is another kind of concept that we're going to go through. So namespaces, we cover this a little bit though. There are multiple virtual clusters backed by the same physical clusters. And namespace is just a collection, in my mind, of pods that you can access there. And I'm going to show you 2 namespaces I created in the demo. So logical, separation, and isolation. Each resource type is scoped to a namespace, and then tenant for environments with many users, teams, and projects. Let's go through services, the other meat and potatoes. So we've gone through deployments, we've gone through pods. So services, they define a logical set of pods. They identify selected using labels. Essentially, it's a virtual load balancer in front of pods. And they're different types of load balancers. So you get, and my favorite is obviously the load balancer service, which you're going to create. And that kind of is a service in front of pods, and it kind of daisy chains round robins between other pods there. So it's this service is a service type load balancer, basic layer 4 load balancer. You also get a higher version called Ingress that allows you a little bit more configuration. And each service has an assigned IP in the application load balancer. And there's the YAML for it. You can see there, the kind is a service, the type is a load balancer, and then the port we're going to do to access the load balancer. You also get other service types. You get cluster IP, and then you also get node port. We'll go through that in the demo. But basically, those 2 types are internal to the cluster and reachable from only within the cluster. Let's go through an example of the manifest for service. So we have the kind, which is a service, the selector, which is the app. So it's going to access that app, and that the application is the label that we specified. The type is cluster IP, or you could do load balancer. And then finally, the port that we're going to access, that's the port coming in from the outside into the service. And then the target port, that's the port that we're going to access inside of the pod. So I'm going to access from outside the cluster, port 80, and inside the pod, I'm going to access port 9376. Finally, this is the final slide, then we're going to do a demo, and I'm perfectly on time. Networking in Kubernetes, and this is the most difficult part of Kubernetes, because you think about it, I've got worker nodes, pods, namespaces, load balancers, ingress, services, and they all exist actually inside a network, allocating resources there. There's pod-to-pod communication, pod-to-service communication, external to internal communication. So I'm not going to kind of overwhelm you with that, but the easiest way to kind of think of this is that everything runs inside the cluster, and unless you're declarative, nothing comes out. So, and you have to be really specific of that, because you might want to deploy a pod. If you don't specify the network specifics of that pod, you won't actually see that pod. So for the demo, I'm actually going to use the same demo that I've specified in the link out that I did, except that I've taken it a little bit step further, and I've added a little bit more meat onto the example, so I can kind of show you a few specifics around Kubernetes and go a little further into our demo. So, okay, so Hazem, if I lose you, please just remind me that my slides may or may not be working. You should see my Visual Studio here. I'm going to make it a little bit bigger because I can see that it's a bit small here. That's bigger. Yeah, that's bigger. And so I accessed all of this via the and I created my little application. I started off by going into start.spring.io. So here's my little web browser. And start.spring.io has something called a Spring initializer, and this is all going to be in Spring and Java. And you can specify the specifics of here. I'm going to use an H2 database, which is a fast in-memory database for the example. Spring Reactive Web, and I'm going to build a REST service to connect to that database, and then the Reactive JDBC driver. And then I can click on Generate, and it's going to give me a little demo project that I've kind of already loaded in to my Windows code Insider, Visual Studio Code Insider. And then you get the project here. I've got my little terminal open here, and you get as a little Spring Boot application, and I've called it Reactive To Do application. And I'm not going to bore you on the pom.xml, but it gives you a pom.xml and with all of your dependencies. And this is just spins up a basic Spring application. We're going to create our application now from our already a skeleton project model. First thing I want to do is I want to actually create a to-do.java because it's a little to-do application here, and I want to call this to-do application here. And I just did the iCode Java conference yesterday, so I haven't actually changed that. I want to go into my snippets, make sure my snippets are loaded. Yay! The demo is great when you have snippets. And then I want to go iCode Java and iCode to-do. And then the to-do application, this little DTO, it binds to the table there and just has an ID, title, and completed. Because we're going to create to-dos, so I just need an ID, a title, and completed. I've got all my getters and setters there. Next, I want to create a repository. So I'm going to go to-do repository.java. And that repository.java there, I'm going to actually make it extend off a reactive repository, and I'm using Spring Data. So it uses the magic of injection to do all of that. And I'm going to go the repo. No, that was the wrong one. iCode repo. And that you can see there, it's just a to-do repository, extends reactive CRUD repository. And then I've got another little method here, find by title, if I wanted to do find by title. And that uses the magic of Spring Data to go and find all of my objects in my repository. Next, I need a REST controller. So I'm going to call this to-do controller.java, and I've got my REST services here. So I'm going to call it this here, the to-do controller, and it's got a nice little hacky cross origin to let everything in there. And then I've got a REST controller, and it's auto-wired to my to-do repository. And then I've got some mappings here: get all, get by ID, add to do, update to do, delete to do. So your normal CRUD functions, and these are all reactive. So if you know reactive repositories, then you don't approach this in the mindset of blocking. It's non-blocking, and we're going to show you that with an example that I've got here. So I've got my to-do controller, and then I'm going to actually go into my reactive to-do application and start to access that data. So then over here, I'm going to go, I don't want the app. And the app really goes in, it creates the table if it doesn't exist. It creates a stream of to-dos, and the to-dos are high. This is my first to-do. This is what I've accomplished, and this is a secret. And then it goes save all of those, and then flux from stream, then subscribe, because remember, it's not blocking. So you get a stream, and then I have to go subscribe. And then the minute I do that, it actually goes and stops the stream. It will find these to-dos there, find all, and then block last, and then find by ID, and then block. And then also finally find by title. If you want to know a little bit more about Reactive, I've got a session scheduled at the Reactor coming up in 3 weeks' time on reactive systems and creating reactive systems, where I really kind of show you how simple it is to create reactive systems, that you can really go from database all the way to web and create that data flow and via your front end. We're going to do that today a little bit, but I'm going to go a lot more detail in that session. So I've got my system here. Now I'm going to actually run it because it uses an H2 database. So I can just go run and debug, and it should actually create a REST service that I can check on localhost. It will say connecting to database, finding the to-dos, yeah, created my to-do, and I should be able to go into my Chrome and localhost, and I should say, yay, this is my first to-do. This is what we created. This is my first to-do. This is the one I have accomplished, and this is a secret. So the application is created. So now what do I do? Now what I do is I can make this into a container. There's multiple ways to do that, and I've done a few sessions where I actually built Docker containers. But recently with Spring 2.3, there's something that was released called build packs, cloud native build packs. Remember when I said to you cloud native? Cloud native is the ability that the application knows it's running in cloud. So the cloud native build pack scan your application, find out all the dependencies, and actually builds the Docker instance for you without you having to worry about optimizing your actual container. So let's close all of this, close others, and I'm going to maximize my terminal because now I'm actually working in a terminal now. And you should see here, I'm going to clear that here. So I've got my bash, and I'm running on a Mac. I know, Java developer running on Mac with bash. And I've got my project here running. And I want to actually go in and install, and I've got Homebrew, so I could actually just install my build packs via this. I've already done that beforehand, and to do it on a Mac or Linux, you just go brew, install, build packs, and then tap. Oh, I think I actually installed it. So that's me installing it again. It should actually say, no, you've got the latest copy. This is what happens when you cut and paste on a Mac. It's always confused me that it pastes a line feed. So once you actually have that build packs, and then wow, it's actually going to install it again. Of course, in the demo, I reinstall build packs. There, okay, it did it again to reinstall. It's ready. Yay, Rory. So once I have it there, I can actually go into my project and I can say, please go suggest a build pack that I'm supposed to use. You can go packed, suggest builders. And then it's going to go scan your project and say, I think you need this, that to do it. I see that you use Java. I see that you use Python. So the build pack that is suggested here, it's going to say, you can use this one by Google with .NET, Go, Java, Node.js, Python. This one over here, which is, and that's gcr.io build packs builder, Heroku build packs, and that's for Java, Ruby, Node.js, Go, Python, and PHP. Paquito, which is a brilliant one, and then the build pack. So the one I'm going to use actually is neither of those, because I'm going to use the sample one that they use really for demos because it's quick and it kind of doesn't take too long in demo. So I'm going to go, okay, cool, packed, build, and build the project that you see here, this project here in Alpine Linux. And Alpine Linux is that small 4 megabyte big container. So I'm going to go pack, build, builders, CNBS, sample builder, Alpine. Hit enter. Didn't like that. Oh, sorry. I left out half the command there. And there we go. And I'm going to say build it to the name of the container. I forgot about that. Rory Preddy /Spring Cloud, because I'm going to put it into Docker Hub. And then I'm going to add verbosity because I want to show you what it actually does. So I'm going to hit enter there. And then it's going to say, okay, it's on verbose. It's going to scan my project. It's going to see it's a Java project. And it's going to start to add all the layers there and build my Docker container. Remember, the idea here is we're building our Docker container so we can actually take the Docker container, chuck it in the Kubernetes cluster, which I've created beforehand with a DevOps process. I'm going to show you how to run that with the DevOps. And then once we've got this container there, I'm going to actually spin it up and show you that. So you can see there, it's actually going creating build with the following build packs, Java, Maven. It's analyzing that, restoring the nettle labor, adding some encryption to the layers, then running Maven there. So it's running the build pack for you there and setting all the properties that you want and done. Now, that build pack, the Docker image, Rory Preddy Spring Cloud, I can access that. So if I go Docker images, It's run here with Rory's Spring Cloud. If I analyze it, it actually uses a nice SHA mechanism that you can't actually get it because it secures the cluster. So I'm not going to analyze that, but it uses Java and Maven and all of those different layers there. Next thing I want to do, once I've got this pack, is push it to Docker Hub. And you can push this to ACR registry. You can push it to any container registry here. So I'm going to go clear there. And to do that, I just go, I've already logged into Docker. Hopefully, Docker push, and then Rory Preddy Spring Cloud. This push registers to that, and it's going to find all the layers that it needs to include, and then it's going to say layer already exists, and then just going to push the application there, 23 megs for Alpine Linux with Spring and all of that there. Pushed. Now I can run it locally, or I can actually run it into the cluster. But to run it locally, you would actually go in and say Docker run. I'm just waiting for this to finish. Did that do it twice? It looked like it did it twice. Hopefully there's no bugs here. So let's see. Pushed. Okay, great. It says pushed. Okay, finish off. Come back. I need my terminal back. Else I'm going to kill this terminal. Okay, pushed. There we go. I swear that did it twice. Latest digest. I think my terminal's kind of collapsed. Oh, there we go. Okay, so now I've got the in Docker Hub that I can actually go in there into Docker Hub. So I can go here and I can go Hub, Docker Hub, and into my profile, and then I can see that that kind of instance there. When this comes around into Docker Hub, and you can use this as an ACR registry. And there's my registry, there's my instance there. You can click through that and see all the labels for it, and I can pull it there if I wanted to, or tags. Let's go back in here. Now we're going to actually, we pushed it. I'm not going to run it locally because that's pretty simple. I'm going to create a deployment in my, my container in my Kubernetes cluster. Now, my Kubernetes cluster, I've already kind of created it here. And how I created my Kubernetes cluster, let me just show you that quickly. I'm going to show you how to do DevOps in under a minute. I've got my DevOps starter here on the portal, and you can see the cluster I've created, so I can go add. And I'm going to show you how to create a Spring cluster. You can do it also with .NET. And once you have that cluster, it's pretty simple to connect to it. So in my example here, I just went into a Java, Java next, then I choose Spring next, and then I go Kubernetes service next. Specify your project name, your DevOps organization, your subscription, and your cluster name that you're going to use, your location, how many nodes you want, and then you just click on done. And then that's going to actually give you your Kubernetes cluster. That takes about 5 minutes to run. And then you get the Kubernetes cluster and also CI/CD. And I've done DevOps before with you guys in the session, so I'm not going to go through that. And to connect to the cluster, you can see there's a little connect button. I go connect, I set the account, and then I get the credentials. And then it actually connects Docker. You can see that Docker instance there. And you can see Kubernetes is actually connected to that Kubernetes cluster, which means I can use kubectl. From here, I can go kubectl get all, and it already is connected to that cluster. Pretty simple, as long as you connect it. So I want to push my deployment into that cluster. You can see there's nothing in the cluster except for the cluster IP address. And I'm going to push that deployment there. I'm going to say kubectl create deployment, and I'm going to give it the name demo, and it did it already. Kubectl get all. And then I gave it the image name, and that's how quick. And kubectl get all. You'll see there it's got a pod already ready. The cluster IP address, the actual replica set there. You can see the replica set is only set to ready 1.1, meaning they've only asked for one. And then also well, that's the replica set. Sorry, there. That over there is the replicas. And then yeah, so it's done. So I can't access this right now because I haven't accessed a service. So one is I can create a service with a cluster IP address, and that'll just create a cluster internal to the cluster of the IP address. You can see there I can go get all, and it will say yeah. So there is the cluster IP address, and that's internal there, and it's no external IP address. And two is I can actually go in there and use either port forwarding. So if I go port forwarding, and port forwarding is just a nice way to say access that cluster IP address without creating a load balancer. I can go port forwarding, still got 15 minutes in the demo, and then it'll say access that random port locally on your PC. So 60551, I go to my browser here, and I go localhost 60551, and I should have my REST services here. And that's running in the cluster. But I don't want to access that from port forwarding the entire time. I want to control C that. No, control C. And I want to delete my services right now. So I'm going to kubectl delete services -- all. And then it's going to create that. And I want to I want to expose that service there with a load balancer, not a cluster IP. And it's simple as that. I go kubectl, expose the deployment, apps demo, type load balancer, the port outside 80 and the port inside 8080, and then it goes services demo expose. We can go in there and check the get all, and you'll see here now that I've accessed that, it's going to give me a pending notice until it gets an external IP address. It's got a load balancer that it's creating, and I can go check that. Shouldn't take me more than a minute to actually do that. But while we're doing that, we can actually go in and scale our deployments. And this is last time when I did a demo about 3 days ago, where it just did not want to come up. Okay, cool. We've got our external IP address. Thank the demo gods, and I can just go into that external IP address, and this is a load balancer now, and access the load balancer. I can go control, no, I want to go control V. I want to get that external IP address there, copy that, copy, and then go into my Chrome browser, paste in that IP address, and I've got a load balancer. But what am I load balancing? I'm actually load balancing one node here. I want to go in and get in more. So I've got that one node there. I want to go in and now scale out. So I'm going to scale out using manual scaling, and then we'll see how you can also do auto scaling with Kubernetes. So let's clear that. Control space, and then I'm going to go in and the final bit of the demo. On the command line is I'm going to scale out. So you can see there kubectl scale the deployments that I've specified, and then the replicas too. So I can hit enter there, and it's going to say, okay, cool, I'm going to scale out. Remember, I only had one pod, and then I can go to kubectl get all, and it will say busy creating another one for you. So kubectl get all, and you'll see there it's got under the pods there it says running, and then it's busy creating the container created, and the load balancer will wait until that's created and only really allocate that pod when it's ready. So you won't even know if you were an external customer client hitting that pod that was creating. You'll just be allocated with the load balancer when it's actually available. So let's see if it's available now. And yeah, running. So everything's running. I said I've got 2 desired, 2 current, and they both of them are running. Now, how many worker nodes is this running? And this is running on my laptop, which is 1 node. So theoretically, if this is running on, sorry, this is not running. If I ran it on my laptop, it will be 1 node. This is actually running on the server in the DevOps project that I created. Now, I downscaled it for simplicity, but this is actually running on 2 servers. But you don't know which node it's running on. I've said to you, I would like it to run on 2 pods, and it's up to you to actually run it where you want. But it's been clever, and it said I've got 2 servers, each of these DCV3s, 8 gigs of RAM, 2 CPUs or 3 CPUs, and I've actually gone and allocated them, and you can access that and a number of ways to see where it's running. So the first thing that you're going to access is, and I'm going to go make this a little bit smaller, is you can go into your Visual Studio Code Kubernetes cluster plugin, and you'll see there that I've got my Kubernetes cluster, and that's the cluster we created. And you'll see there under nodes, I've got the 2 nodes, and they've got agent pools there. And then I can access those nodes, and I can go into each one of those nodes and go introspect them. So I can see there that my demo application is running on one of those nodes. can go into the YAML for each one of those and see that, wait a second, it's the demo label there, the API version, it's part of a replica set. The container there is Azure Spring Cloud, and I can go and dig deep into here via the Visual Studio Kubernetes cluster. I can also go in there, right-click on the cluster, and I can go open dashboard. And this is the official Kubernetes dashboard, and you'll see there that it binds to a port, and it's going to use port forwarding, and it takes a few seconds. It's always very confusing because it doesn't come up. And this is the official one, and this gives you exactly kind of the same kind of interface as the Visual Studio interface there, and it gives you the namespaces, nodes, persistent volumes, role storage. And you can see that the namespaces, I've actually got a default namespace, and I've also got one that we created in the CI/CD, but I've allocated my pod to the default namespace. I go into pods, and you can see there's the demo that we're running there, the status for each one of those pods. And I can actually see the cardinality between pods and nodes now, because I can see my nodes. And my nodes then has 2 nodes, and each one of them is running a agent pool. And then on each one of those agent pools, you might get also multiple pods in there. And you can drill down to it. This is not really part of the session here, but just understand that you can access the cluster both from the Visual Studio Code plugin and also the Kubernetes dashboard. Let's go into the cloud now. So I've got my my portal, my Kubernetes portal here with my cluster. I don't care about connecting, and you've got a lot of access here on your Kubernetes service. I can see access control, but I've also got another dashboard here, Kubernetes resources, where I can see namespaces on my Kubernetes cluster, workloads, services and ingresses, and access a lot of the dashboard-like features via the Microsoft portal. So you can see here namespaces. I want to find the default one with our demo pods there. I'm going to find those demo pods. You can see here labels. Okay, so don't worry too much about that. Let's go in, and what I want to show you here, oh, I really went back there. Let's go back there. From the namespaces, is I can find the service and ingress, the node pools, and this is where the auto scaling is nice, because if I wanted to create a auto scaling pool, I actually have to do it in a different way. But I can scale out if I wanted to create, and these are non-virtual pools, so physical tin, and you can see their node count 2, and then I can scale out. So we're going to scale out right now to 3 servers, and you can do that either through auto scaling, to creating an auto scaler cluster, but this is a manual scaling. I'm just going to go 3 and total cluster capacity, and then I can just go save, and I've just scaled it out. And you can use that auto scaling based on CPU, on usage. There's a lot of different ways. It's not really part of the session here. You also, and finally get, and I'm going to show you the last part of the demo, is the insights, the logging. And this is really where the cloud comes handy. So I've got my insights here, and I've activated my insights, and it gives you the some settings here. You've got your view all clusters, recommended alerts, and then I've got what cluster nodes, controllers, containers, and deployments. So you can see here I get, I want to make this bigger, and let's make it bigger. I've got my node CPU usage. I've got my node memory utilization, my node count. So we should actually see this blip here, because we're deploying it another node count here. So if we do a refresh, we should actually see eventually when that comes through, the node count will actually go up. So I was in the morning, so I wanted to show you 3 nodes, and now on 2, and then it should come up. Then active pod count from my allocation, and how many are pending, running, unknown. And it's a really nice dashboard to kind of see your production grade AKS cluster running in the cloud. So on cluster, and then nodes that also give you some insight onto to nodes. And you can see here now I've got, this one is coming up. I've got my nodes here and which apps they're running on, and these are physical servers here that they're running on. You can see my demo app there, and it's running that cluster. I can get individual kind of drill down for each one of my my node. I can even go view live data there and see specific trends for each one of those. So there's a lot of kind of power in there. So it's already done there, and I should, if I go refresh, see my other AKS agent running on that server, and let's see, it's going to allocate. So the scheduler is going to allocate those apps there, and so the servers, there it is. That was quick. It's going to go in and find my demo app. It hasn't done it yet, but it's going to find the server. It's going to say server's up. Go and allocate those instances to it. And then finally, so have a look at that and go through that. We've got controllers, also containers, so you can go into containers, and then deployments. If you want to do a deployment by YAML file, you can actually do it via this. There's a lot of power there. We also have some nice development tools. If you want to go into dev spaces, so dev spaces is a nice way to run Kubernetes locally on your PC via a sidecar container that runs in your PC that you can connect to it, and then it will push it to there without you having to do port forwarding. Yes, I know, really cool. So have a look at that, local processes with Kubernetes on dev spaces. We also have our deployment center. So this allows me to trigger my CI/CD if I want to. It's clever enough to know that I created this from CI/CD. So I can go in there and trigger my deployment centers there, and it gives me, you can see there, my build pipeline. I can click through that and goes into Azure DevOps, shows me my build pipeline and all of the different jobs that did to push it there. And this was all automated from this process I showed you with CI/CD, Helm package, build an image, Helm, install Helm, publish the artifacts, and then finalize the job. So you can get access to all of that via the deployment center, and that ties into your Azure DevOps. You also get policies, so you can actually set your compliance policies, and then you get the normal alerts and monitoring, diagnostic sense, and then you get advisor recommendations. And you can also access all of the features on the portal via, and let's just close that, via the command AKS. So you can go AZ, AKS, or AKS, and there's an entire CLI. I'm not going to go through that right now. So AKS like that. And you'll get an entire service to be able to do exactly what I said via the portal. So browse, create, update, delete, update credentials, add-ons, all of that, get upgrades, install CLI, all of that that you would be able to access via the portal. So I've got 4 minutes for questions. Thank you so much for your time today. I hope this has been informative and not too overwhelming. I'm going to put on the slides again for the PowerPoint, and then we're going to take some questions in there. Let's go Kubernetes and presenter view. So Hazem, hi, did we get any questions?
Yeah, we got a few questions in here. I'm gonna just, well, yeah, so there was a question from Amar, and it was about can a pod span more than one node, or pod should run in only one?
No, pod should run in only one node. You can't actually split it up. Really think about it. It's a virtualization for an application that you're running there. You can have, like I said to you, a sidecar pods that can run across multiple nodes, but you also, there's multiple patterns. There's design patterns you want to look at for how, what you're trying to do and what kind of pods you want to create though. So a pod is a Docker container, really. It's a Docker container, and you're going to run it on a node, a physical server, and that node might be virtual or physical, and you kind of want to run it as close to the bare metal tin as you can, and not do that. Yeah. So next question.
And so some questions came during the presentation, and you might have covered some part, or you covered that and answered it already. There was one on the features the pod provides, why Kubernetes does not directly interact with the containers.
Okay, so Kubernetes, so it does directly interact with the containers, but the control plane doesn't really want to. So you've got the control plane, and then you've got the actual worker nodes. And those worker nodes might be sitting on a server in another place in the world. And the only way it's going to be able to do that elegantly and efficiently is via a protocol like TCP/IP or RESTful services, and else it's going to overwhelm your network. So it's more of a performance improvement to be able to, now you can access your pods directly. What I didn't show you is that everything that I did there, you could have actually spun up your pod, allocated the network, done all of that yourself, exactly like you would do a Docker, but you don't want to. You want to be able to use Kubernetes to use enterprise level container management to do fire and forget. Here's a pod, here's a service, here's something I want. Just put it into a cluster and get it running. So you can hack it to your heart's content, even access the RESTful services, but you don't want to. Next question.
So this one on your view, so with serverless also being widely adopted, do you think Kubernetes will eventually be phased out, or will there remain a need for it as well?
Serverless is not Kubernetes, and that's, I need to categorically state though, because serverless is typically and was created for event-driven architectures. So I get an email, that email comes in, it triggers a short-lived container, and that container then dies and then go somewhere else though. That's really the business case for serverless though. You can run an Azure function in a Kubernetes cluster. You can do that. And you could, if you wanted to hack it, run a Kubernetes cluster in a serverless function, but they're really focused on what you're trying to achieve. Serverless is trying to achieve event-driven architecture, and Kubernetes is really doing container management. And it doesn't care what you do with those containers. You could actually run GPU servers, you could run containers that were long running or anything like that, but it is there to drive your ship of containers ahead. Those are the two differences.
There was a question on the pod node limit. What will be the best practice?
How much money do you have? It depends on the application you're running. Classic consultant answer. So typically what you want to do is, look at exactly how many layers, your service layers. So you would have your application layer, you would have your database layer, then you would have your service layer or your integration layer, and then you would look at what makes sense to create an application. Remember in the beginning of there we had a layer that did Django, and it had an integration layer and then a Django layer, and you might have a database layer there also. So it depends on the level of complexity of your application, but all of these that I've defined, that I've just specified, there are tried and practice mechanisms to do that. So if you go to the Django forums, if you go to the Spring forums, they already know how to do that. And Cloud Native Build Packs does all of that for you. It just goes in, analyzes your requirements, and creates everything for you, because it's a jungle out there when you look at how do you create your containers. So look at Cloud Native Build Packs and see how you can actually go in and create your clusters, or start looking at also in your relative ecosystem, Java, .NET, and Python. What do they recommend if you want to create your different service layers for your application tiers?
And the last question, there was a request to talk a little bit more about the relationship between labels, services, and deployments.
That's great. And I'm going to give you homework, whoever asked that question, to go to that URL there, and it's all available. We've run out of a little bit more of time, but it's all available on https://Kubernetes-Java. I've put the slides there, my Twitter URL, and also the labs demos that I've done here today. And we have an architectural center in the same portal there that allows you to see all of the architectural patterns around Kubernetes, sidecar containers, multi-containers, services, labels. How to do all of that is all via this link that I've provided for you. Thank you so much for your time, Hazem, and I look forward to the next session. So the next session I'm going to do, I think, is on either reactive systems, and there's another one I'm going to do in a week's time.
Yeah, I was going to highlight that just now, actually. So let me start presenting, and you can give a very quick highlight to our community about the two coming sessions that you are doing with us later this month. So okay, I'm just sharing my slides. Just give me a second. I'm going to take over.
Yeah, you take over. I remember end is the bad. There's a button called end, and that just like kills everything. Yeah, I'm not doing that. Hey, I've learned that with Zoom and with Teams and for everything else. If there's a button called stop, don't press it.
All right, so yeah, my presentation is up. if you want to talk
Yes.
about the two upcoming
So
sessions
upcoming sessions, and it's great. I'm going to show you serverless functions. We're going to talk a little bit about serverless and microservices and containers. And it's a great question that was answered today, because now we can actually see the difference between the two of them. And I'm going to use Azure code spaces to create serverless functions. This is an incredible session. You really want to come to this one. Java 11 and serverless functions. Even if you're not a Java developer, it's a great session just to come see what serverless functions is about. I touch on logic apps also using code spaces to actually spin everything up in the cloud. The next session is integrating reactive APIs to your traditional relational databases. We use H2 here. We created that relational input with Flux and with monos. I'm going to go through a little bit more detail on that. I'm going to go deeper into the mechanisms around it, a little bit of a history to show you exactly how and how it works in the background of reactive systems, and how you can build an end-to-end system all the way from the front end running a Angular system to the back end running MongoDB, containerized and in the cloud, and how you can connect them all to create an incredible reactive end-to-end non-blocking system.
Amazing. All right, I'm gonna share also a couple more that are happening next week, and I highly encourage everyone in the community watching us today to join Rory's session next week, and also later this month, sorry, and also join the ones we're doing next week. So I want to highlight just 3 more that are happening on Sunday, Monday, and Wednesday. So there is a session on PowerShell fundamentals, and in this session we will discuss how to utilize automation, runbooks, and schedule tasks to simplify automation. So this will help you if you are managing an Office 365 on-premise environments using Active Directory, Microsoft Exchange, and all of that. And on Monday, we have our regular workshops at 4 o'clock local time. So in this week's workshop, we will be covering Rust programming basics. Rust is a programming language that empowers developers to build reliable and efficient software. And in this workshop, we will explore how to start coding in Rust. So you will require to use VS Code and use the run extensions to use that in the workshop. And on Wednesday, that will be earlier on the day, local time, we will be having a session on using Azure Data Studio with Python for machine learning. So for data science, data cleaning is the process of identifying incorrect and incomplete and missing data, replacing it or adding as needed. So this session will be an opportunity for you to discover available resources and tools to build and test with Python and machine learning. I highly encourage you also to check out our calendar of events on meetup.com and to subscribe to our newsletter, subscribe to the YouTube channel. I posted a lot of links in the Q&A section where you can check out the upcoming sessions with Rory and check our calendar for all the upcoming events we're doing here. And there is also a link for the survey. So the survey helps us learn more about your interests, the topics that you'd like to see at the Reactor, and you will need to use the event code for this session. It's 8161, so use it in that survey, and this will help us bring more sessions to you on the topics that you like the most. Thank you everyone for joining us today, and we hope to see you in the coming sessions. Goodbye.
Thanks everyone. Bye.